Today we are working on solving systems using substitution. So yesterday we worked on solving systems by graphing. So instead of graphing today, we're going to find an order pair that solves a system of equations. So we are going to use substitution. Go ahead and read through this. You don't need to write it down, but I need you to read through it a couple of times. Okay, so what this is saying, this substitution method, is you can replace one variable, and we're going to start with x's and y's for the first part of the lesson. So we're going to replace variables with equivalent expressions containing the other variable. So what's important here for you to remember today is the equal sign. When I have something, let's say y is equal to 2x plus 4, at any given time I can substitute my y for this entire value. And the reason I can do that is understanding that they are equal. These represent the same thing. To break it down even more, if I had 2 equals, what does 2 equal? Well, 2 equals 2. These are the same thing. So we can say whatever is on the other side of the equal sign is equal to this variable. Today we're going to start solving systems using substitutions. 2x plus 2. Here, this y equals negative 3x plus 4. So, the first step, and we're going to follow these steps very closely throughout the lesson. Okay, step 1, step 2, step 3 here. Step 1, write an equation containing only one variable. So, let's start with the first one. Y equals 2x plus 2. We're going to substitute this y, okay, right here that I circled, is equal to negative 3x plus 4. So I can take this y and substitute it in this equation because they are the same variable. Now, understanding that this is considered a system of equations. It's not just two random linear equations put together. These are considered a system of equations, so therefore you can substitute your letters back into. So let's keep going. Now we need to solve. So we have negative 3x plus 4 equals 2x plus 2. Well, the first thing we need to do is combine your like terms. So I want to get this x over. So we draw lines to the equal sign, 3x. We're adding 3x because I got to get these to cancel. So I get 4 equals 5x plus 2. Now, continue to combine like terms. 4 minus 2 is 2 equals 5x. We want to get x by itself. So 2/5 equals my x, which is the same as 0.4. Okay, so 0.4 and 2/5 are the same. That's what my x equals. Now, the second step here is solve for the other variable. Now that I know what my x value is, I can choose whichever one of these two equations I would like to plug x back into so we can solve for my y. Now, let's remember that we're looking, just like yesterday when you were finding your ordered pair, you were solving this by graphing. Today we're looking for an ordered pair as well that solves this system. We know my x value is going to be 2/5. So now we need to find my y. So y equals 2x plus 2. That's one of my equations. I'm using it because there's no negative in it. I can take my x. What does x equal? Well, x equals 2/5. So plus 2. Or you could have put 0.8 in. That works as well. So here, they substituted my 0.4 with my x. This was my original. And for x, 2 times 0.4 is 0.8. Add my 2, we get 2.8 is my y. So here's going to be 2.8. This is my ordered pair. Step 3 involves checking. So we said 0.4, 2.8. Here's my solution. There's my ordered pair. We can check it. Plug in. Remember, this is one of my equations from my system of equations. Here's the other. I would recommend using this one to plug it back in and check because you solved it using this one. So then let's just use the other. So I'm going to go back to that part there. Here we used on step 2, we used the first equation. So now in step 3, we want to use the second equation. Plug in your x and y values, solve it out, checks. You know you did it right. Let's look at another one. This one you're going to have to use the distributive property. So before we were fortunate and they were set up in the y equals mx plus b form. Now they're not. So we need to solve for something here so we can substitute. Immediately I see this y with a leading coefficient of 1. That's going to be my easiest one to solve for. So let's solve. Negative 2x plus y equals negative 1. I need to get y by myself. So we're going to add 2x to both sides. I get y equals negative, let's go positive first here, 2x plus a negative 1. Now, because I now know what my y value is here, I can take it and substitute it. So here this is what we just did. I can take and substitute it with one variable. So let's choose, we change this, so we need to plug y in to here. So you can see here, this is my y. So we plug what y equaled from the first into the second. 4x plus 2 times my y value, which was 2x minus 1, equals 12. Next thing that they're going to do here is they're going to distribute this 2 to both. We talked about little rainbow, big rainbow earlier this year. 2 times 2 is 4x. 2 times 1 is 2. 4x minus 2. Now I need to combine like terms. Add my 4x's together, I get 8x. Add a 2 to both sides. I get 14. I'm going to divide by 8. I get 1.75. So x is 1.75. Remember, we're looking for an ordered pair that solves this system of equations. So 1.75 is going to be my x value. Now, step 3, I need to solve for y because I already know my x. So here's my first equation again. Negative 2x plus y equals a negative 1 was your original. So I'm going to take my 1.75 because previously we just discovered that x was 1.75. I'm going to plug 1.75 or substitute that into it. Negative 2 times 1.75 gives you negative 3.5 plus y. We're going to add 3.5 to both sides. Negative 1 plus 3.5 gives you a positive 2.5. So I have 1.75 and what's my y? 2.5. So the last part here would be is checking. So since supposedly 1.75 and 2.5 is the solution, you could go back through and check them. Okay. Another example here. Go ahead and read it. Pause the video. Okay, so you need to pull out the important information. You're going to have to do this on this own. So here we're going to let V equal vans. C is going to equal my cars. And I need to come up with two equations that's going to give me a system of equations. I can have C and I can have V plus C. So the number of vans and the number of cars we said had to be less than 5 because there was 5 chaperones that will each drive the car. We know that between the number of vehicles, I can only have 5 vehicles going. I also know 7 people can ride in a van and 5 people ride in the car. Now, 21 here, be careful with it. You didn't write 26. Just remember you got to do your 26 members going to the beach plus their 5 chaperones gives you your 31. So first thing is we need to substitute. Once again, we don't have a direct like y equals or v equals, so we need to create it. So this front one does not have any coefficients, so it's easier to solve. So we're going to subtract v from both sides, and we're going to get c equals negative v plus your 5. This is a positive 5. So right now I know C is equal to negative V plus 5. So I can take my second equation and wherever I had a C, plug in my negative V plus 5. So I have 7V plus 5, negative V plus 5, so I need to distribute this 5 to both. And I'm going to get 5, negative 5v plus 25 on the big rainbow. Combine your like terms. 7v plus 5 gives you 2 plus 25. And then we need to subtract 25 from both sides. We get 6 divided by 2. V is going to equal 3. So now that I know v equals 3, I need to solve for what my c is. So what you're going to do is go back to my v plus c, my first equation, and plug in what your v value is. Well, v was 3 plus c equals 5, so we can subtract 3. 5 equals 2. So I'm going to have v equals 3 and c equals 2. So I have 3 vans going and 2 cars going. Now, is this a possible? You can check it, but is this a possible? Well, plug it into the second one. If I have 3 vans going times my 7 people it can hold, that will carry 21 of my passengers. If I have 2 cars that carry 5 people, that means that's going to carry 10 of my passengers. So if I have 10 of them going in cars, 21 of them going in vans, that equals my 31 people who need a ride. So the answer is correct. Our assignments.